Hello, third grade mathematicians. As you enter the room, you were handed a playing card. If you could, please find the table that has the same suit as the card that is in your hand. That is the table that you will be sitting at today. Okay? As you are finding your seats, let me go ahead and introduce myself. My name is Tiffany Hilliard, and welcome to my session on Unit 1, Place Value Concepts. Now, at your desk, you also have a IFD, the Instructional Focus Document for Unit 1, both Bundles 1 and 2. We're looking at Bundle 1 first. If you notice, Bundle 1 is composed of 3 SCs, 3.2A, 3.2B, and 3.2D. Let's start by breaking down 3.2A. Now, for each SC, you will see as I go through, we'll break down and understand what the verbs are, the actions the students are doing, what vocabulary is embedded that the students must understand, and if there are any variety of ways in which the expectation list that the students should be able to demonstrate their knowledge of these skills. For instance, this particular one has 2 verbs, decompose and compose, numbers up to 100,000 as a sum, which is a vocab word. They should know that the sum is the solution to adding numbers together of many thousands. They need to know what those are. So many hundreds, so many tens, and so many ones. And they have to be able to do so using objects, pictorial models, and numbers, which includes the expanded notation. For the sake of time, I'm going to jump right into my first example of how this SC can be taught using objects. Okay? Now, for place value, the best object is the base 10 blocks. So notice I have base 10 blocks here. So the number I have composed is 126, okay? 126. This is the number that I have composed on the board. Now, I would ask my students to use the blocks to determine another way to write 126. So, of course, naturally, my students would say, well, I know that this block is equal to 100. These 2 10s equal 20, and those 6 ones equal 6. So that naturally lends itself to writing 126 in the expanded form using 100 plus 20 plus 6. My extension to this would be, however, is to get them to understand that these place values are fluid, meaning that they can change and be swapped out for one another as long as the value doesn't change. So I would ask my students, well, is this the only way I can compose 126? Can I switch anything out for something different? Meaning, can a 10 be swapped out for 10 ones? So I will lead them to understand that this 10 does not have to stay a rod. It also could be equal to 10 individual ones. So now that leads them to rewrite their expanded form in a different way. Now they still have the 100 block, but now there's only 1 rod in the tens place. So the tens place now has a value of only 10. Now there are 16 ones, so there's no longer just 6. Now we're going to add 16 ones. So there's another way that this number can be written in the expanded form, and that is 100 plus 10 plus 16. Okay? We can go on and on with this. I could trade this 10 out for another group of 10. And it'd be 100 plus 26. I could trade the 100 out for a group of 10. We could keep going on and on. So the students have a blast with this, trading them out and figuring out and finding out that these numbers are interchangeable with one another. Okay, another way, moving from the concrete to moving more towards the abstract. Okay, we're gradually moving from concrete to the abstract. Okay, so another way that I've done this is I've created note cards. You see at your tables and I've provided you with a set of note cards of your own. On these note cards, you will see that there is a note card for each digit in the place value. So for ones, you have a 0 through 9. For tens, you have 10 through 90, 100 through 900, 1,000 through 9,000, 10 through 10,000 on your cards. So what I would have the students to do is I would have them to draw a standard form number out of the stack. Whatever that number is, they will compose it using the cards that were provided. So if I were a student, I would have had to dig through the stack, but for the sake of time, I have already pulled out the numbers that I need. So ideally, the students will compose 9,000 plus 5,000 plus 600 plus 70 plus 3. Just like the extension with the place value blocks, with the base 10 blocks, where they switched out the 10 for the 10 ones, I would ask them to do the same thing here. But what is another way that this can be written? Is this the only possible solution? So I would have the students to decide how and where and when they can swap out the numbers for something different. So let's say, for example, the student said, well, I have a 400 and a 200. So I could, instead of having just one 600, I could break this down to be a 400 and a 200. And they've now composed 95,673 in a different way. Again, this could go on and on. They could have, the students can swap out any of the place value for any other combination that creates the same amount, and they will notice that the value doesn't change. This also requires a thorough understanding of the equal sign, meaning that the two sides are balanced, which is a first grade SC, that those two sides are balanced. And as long as one side equals up to be the exact same as the other, then it doesn't matter how you compose it, as long as in the end they match and they are the same. Okay? Now, I would like for you to find someone in the room who has your same number of your card, but a different suit. Once you get with that partner, come up with different strategies and ways that you can use these two sets. All right, those were great ideas you guys shared. Thank you for your collaboration. Hopefully you jotted down some of those ideas and can take those things back to your campus immediately. All right, now I'm feeling like Oprah today. Okay, you get a bag, you get a bag, you get a bag. Everyone gets to keep their bag of note cards that were placed in front of your table for you, so you can get started with the activity that I just showed you in your classrooms. All right, let's move on to 3.2b. Again, I like to begin by breaking down this essay. It's a lot of words. Let's break it down and see what it means. Okay, so I want you to identify the verbs within this standard. Yes, describe. So what I have highlighted is describe, and it's the only verb that the students are expected to do. So when you think about describe, think about what are your students doing? What does that look like to describe something? How do you usually describe something? Yes, the use of your words. So your students will have to use their words, okay, to describe. That can be verbal or written, preferably both, okay? But in order for them to describe, they have to have some kind of background knowledge. So you notice behind me, I pulled out my manipulatives. Doesn't matter how old, no matter what age, manipulatives are always a great way to build that understanding of place value knowledge, okay? Now, one thing that kids need to understand is how place values are built and created. I've always used this little analogy with my kids that 10, the base 10 system, is built around 10 because 10 is magical, right? 10 is like a magician. It makes things change. So if you've ever been to a magic show or seen a magician on TV and they move the scarf and all of a sudden there's a dove in their hand, or they put a scarf in the hat, pull it out, it's now a rabbit, right? Every time the magician uses that magic word, abracadabra, something changes. So 10 is like a magician. Abracadabra, things change, right? So right now we have a single 1. But as we build and count, we gather 10, we now have a 10. As we begin to count and add up our 10s, when we get a stack of 10 of them, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, we now have 100. And the same when you are stacking hundreds. If I have 100 and I stack 10 of them, I end up with 1,000. So every time a group of 10 gets together, it makes something new. As the students manipulate these manipulatives and as you use them to help them build and to compose and decompose, you're building their understanding of this mathematical relationship within the base 10 system. Now, at this point in the unit, it's kind of difficult to incorporate the expanded notation, considering that the students do not have a true background with multiplication. Coming from second grade, they've currently only used repeated addition, and in the unit so far, we have not covered multiplication. So these two SCs, 3.2a and b, are ones that I would like to revisit once multiplication is introduced, okay? But at this point, you can still introduce to a and b without the expanded notation, but once they have that multiplication background, you can come back and revisit to address the multiplication standards. What you should have highlighted is compare, order, and represent. There's 3 verbs within this one standard. So that's 3 different things your students are expected to do. They have to compare the numbers together. They have to put them in order, least to greatest or greatest to least, and they have to be able to represent them using greater than, less than, or equal to, okay? So your students have 3 different skills that they're expected to be able to do within this standard. When you get with your partner, what you're going to do is you're going to use your Venn diagram that's right on your table to discuss the differences and the similarities between these 3 verbs that you are asked to use within your classroom. All right, so now that you have compared them, I want you to share out and let me know what did you and your partners come up with? How are comparing and ordering and representing numbers using the symbols similar? What are some of the same skills or strategies you can use for all 3? Then I want you to share out and tell me some of the things that you have to do differently in order for them to master each of these skills individually. All right, I heard some really great things. One thing I heard was that when you are comparing and ordering, that if you are able to put them in order, you are also able to compare them. That is an awesome observation. So if your students are able to compare and order numbers, if they can do one, they can do the other. And they rely on the same skill, which is understanding that a digit has a value only based on where it is placed in the number. So for example, I have 3 numbers listed on the board. I have 741, 174, and 471. Okay, how many of you have had the students who look at those numbers and be like, she wrote the same number 3 times, right? Because it has all the same digits. So what they have to be able to understand is that each of these numbers are different because the digits are placed somewhere differently inside of each number. So looking at the 4 specifically, I have a 4 in the tens place, I have a 4 in the ones place, and a 4 in the hundreds place. What you can do, pull out those manipulatives, okay? Regardless of age, these manipulatives allow the students to understand the concrete of what you're saying and what you're doing in your classroom. So what I would have my students do is identify the number, and then we're building it depending on where it is placed. So with the 4 tens, they will pull out 4 of their tens rods. With the 4 ones, they will pull out 4 of their ones rods. And for the hundreds, they'll pull out 4 of their hundreds blocks. Okay. Now our board is running out of a little room, but they have their 4 blocks. So then now they can be able to see that, okay, even though it's 4, yes, there's 4 of each object, but they look very different. You can see visually that these 4 ones take up a lot less space and have a lot less value than the 4 tens and the 400. So the students are now able to visually see the difference between 4 tens, 4 ones, and 400s. If you allow those students those time to play with those blocks and to use those hands-on manipulatives, they will solidify that concrete and be able to build upon the concepts of what it means to compare and to order numbers. Okay, so once they have done this, right, they can begin comparing and ordering using both of these manipulatives, right? So if I want them to place these numbers in order from least to greatest, they have the understanding that they have to compare them by place value, starting with the biggest place value first. So if you allow them to build with their blocks 100 versus 400 versus 700, they will begin to see the order of which the numbers go in. The same is true for comparing. If I want them to compare 2 numbers, I have to do the same thing. Which number has a greater value? Well, the value depends on where the digit is placed and how it is placed. The second thing that we talked about earlier is that they have to know what the symbols mean. Yes, they can rely on the fact that the alligator's mouth is always wanting to eat the bigger number. However, they need to know individually what each one of these symbols mean. So if I were to write a comparison sentence on the board, they should be able to tell me if it is true or not when they read it. 741 is less than 174. They should be able to hear that out loud, read the symbol, and know that this is not a correct comparison. Ready for Bundle 2? Go ahead and pull out your IFD, and let's look at the document for Bundle 2, estimation of whole numbers. Now, the way Bundle 1 supports Bundle 2 is through the use of place value. The students have to understand the place value and the order of numbers to understand how to round them. So the one thing that we're building is the concept of rounding for the students. So there's two SCs within Bundle 2. There's 3.2C and 3.4B. Looking first at 3.2C, and true until you're fast, you know what I want you to do? Yes, highlight your verbs, your vocab, and the different strategies or varieties in which the students may be expected to perform that skill. All right, so what you should have underlined as your vocab is represent. The students will represent a number on a number line. You also will have use words to describe. They will use words to describe the relative size of numbers in order to round whole numbers. Okay? Now, going back to representing on a number line, the students have to be able to represent numbers being between two consecutive numbers of multiples of 10, 100,000, or 10,000. Again, the students have not been introduced to multiplication as a concept. However, they do know how to skip count by 10. They should know how to skip count by 10. They should know how to skip count by 100s, thousands, 10,000. They should be able to, using their knowledge of 0 to 9 and the patterns in numbers, go back to place value, they should be able to know that 100, then there's 200, then 300 follows, then 400, and so on. They should know that it's 10,000, then 20,000, then 30,000, and so on. Okay? Now, the thing about the number line itself is that they have to have an understanding of the number line before they can do this. So it's kind of like a SC within an SC. You have to teach number lines before you can use them to represent numbers. Important concepts for the students to know about number lines is that number lines have no beginning and no ending, right? Which is why most or all number lines have those arrows pointing, indicating that there's more numbers you can't see going this way, and there's more numbers you can't see going that way. Also, they need to understand that number lines do not start or have to start at 0. Number lines can start at any number. Now, our classroom number lines start at 0, so the students start to think that it starts with 0. But you are responsible for teaching them that a number line is just a section of numbers in consecutive order, not all numbers, and it's impossible to put all numbers on a number line that we're going to use for our purpose. So teach the students that the number line can be narrowed down to the numbers that you need at the time that you need it. So if we are working with numbers that are 2 digits, they need to understand that we will use number line counting by tens. If you have a 3-digit number that we are looking to place on the number line, we will need the numbers that are in the hundreds and so forth. Okay? Now, turn and talk to your neighbor behind you about a skill or strategy or even a standard that was mentioned in Bundle 1 that directly supports the students being able to use the number line to place a number between two sets of tens, hundreds, thousands, or 10,000. Perfect. Yes, you are absolutely correct. The students have to be able to write the numbers in order, right? If they know the order of numbers, then they can place them where they belong on the number line. Yes, awesome. So you see how Bundle 1 and Bundle 2 support each other, correct? All right. Now, once the students are able to do so, then they can determine if a number is closer to one set of multiples than it is the other. For instance, if they have the number 27, they should be able to put them in order and determine, is 27 closer to 20 or is it closer to 30? That begins to set the students up for estimation and for rounding. Is the number closer to 30 or is it closer to 20? And so forth with the other place value numbers. Okay, once students understand this and they know how to place them in order, then they are ready for estimation. We're on the last SC, 3.4b. Bundle 2 has one more SC, 3.4b. Round to the nearest 10 or 100 or use compatible numbers to estimate solutions to addition and subtraction problems. Building upon 3.2c, where the students were expected to determine the two multiples that a number falls between on tens, between the two multiples of tens, hundreds, thousands, or 10,000s. This SC builds upon that by now taking the nearest 10 or 100 and determining if a solution is even possible for addition and subtraction. What that says in a nutshell is that a student should be able to, based off of logic and reasoning, of understanding the numbers, determine if a solution is possible. So if they are adding 27 and 14, the student should be able to determine if 100 is a possible answer, if 10 is a possible answer, or if it's closer to 40 or 50, right? The student should be able to determine that just based off of their knowledge of those two numbers. All right, once they're able to do that, then they have mastered this SC. Now, using a number line is still a good idea here because the students can build the concept of estimation and rounding and not just a process. By process, I mean if you're rounding to the tens and there's a 5 or more in the ones place, it's going to round up. If you're rounding to the tens and there's a 4 or less in the ones place, then it's going to round down. That's a process. They don't understand what that means. Using a number line and placing the number 17 on the number line can determine for a student that they're rounding to 20 because it is literally the nearest 10 to 17, right? If they're able to understand that, then they will not have a problem estimating at all. I've had problems with my students with the process because if they circle the wrong number or don't know if they are looking at the number to the right of the one we're rounding or to the left of the one we're rounding, their whole world falls apart, right? But if they understand that it is the placement of the number on the number line, then they will always be able to estimate correctly. A good idea is to allow them, again, the concrete. Give them numbers, whether it be on note cards or dry erase, or if it's counters. Allow them to place the number on a number line where it belongs, so they can physically and visually see what's the nearest 10 or what's the nearest 100 and able to estimate those solutions to those problems.